So let's now take a look at one of the applications of matrices. One of the big things that you can do with matrices is use them to solve a system of equations potentially quicker than using another method. So in previous math classes, you guys have learned to solve systems of equations just like this one. Some of the buzzwords that might stick out for you guys, substitution or elimination, different things like that are ways to solve these systems of equations. We're going to use matrices to actually learn a few different ways that we can solve them using matrices. So without further ado, let's go ahead and jump right in. First thing to note is we can't use matrices unless we create matrices. So what we discovered that we could actually do is we could create a new matrix. And this matrix will be the coefficients of your x and y variables. So I'm going to real quick, just mentally, this would be my x and this would be my y. This would be the first equation and the second equation. So in order to get these coefficients here, what I actually have to do is make sure that I'm in the correct order here. So I see 3x, 4y equals, and then my answer. But down here I see 2y minus 3x. So I'm going to go ahead and take a moment and rewrite that second equation. The second equation I'm going to rewrite as 3x plus 2y equals negative 12. And that's just so that I get that little mental image a little bit nicer. What I'm going to do here is rewrite that top equation. So this may help rearranging those equations. It may help you get the idea of what we're doing here. So I'm going to go ahead and take the coefficients for the x's. Here's 3 for my first equation, negative 3 for my second, and then the coefficients for the y are 4 and 2. So this matrix here represents my coefficients of the different variables. And we'll go ahead and call this as matrix A. Now we're going to create a matrix X. That matrix X are the variables that I'm actually using. So this one is a 2 by 1 matrix, so 2 rows and 1 column. That's just simply X and Y. The very last one that we need to have is the answer matrix, so we're going to call that B. And the answer matrix is a 2 by 1 matrix that's simply just the answers, what it equals. So that's minus 6 and minus 12. So the reason we break it up like this is because if we write it as A times X equals B, where all of these guys are matrices, you'll see that this actually creates those equations. So just as a little quick exercise, I'm going to go ahead and multiply 3, 4, negative 3, 2 times X and Y equals negative 6, negative 12. Now if we multiply these matrices, first and foremost, we are allowed to multiply them because you've got a 2 by 2 being multiplied by a 2 by 1. So this right here is allowed because the columns of the first matches the rows of the second. So I'm going to go ahead and do that matrix multiplication. 3 times X plus 4 times Y. And then we've got down here, we'd have negative 3 times X plus 2 times Y equals negative 6, negative 12. And you'll see that when we break it into these 3 different matrices, it actually creates those original equations back. So we're not doing anything fancy, we're not changing it really, we're just making it look a little bit different so that we can do things with it. So now that we've changed them into matrices, let's go ahead and jump and learn the first method. This is one that I simply call just matrix multiplication. So I still have these equations off to the side here, but let's take a look at what we can do. If we rewrite it like we had before, A times X equals B. Now if this was just a regular old equation with no matrices or anything like that, we would divide both sides by A, and then we'd simply divide B by A and get our answers. But because these are matrices, we can't really do division. So we're going to cheat just a little bit. If you remember back when we learned about the properties of matrices, if you multiply a matrix by its inverse, so if I multiply this by the inverse of A, then what comes out is the identity matrix. And what's special about the identity matrix is that it's basically 1 for matrices. When I multiply the inverse by this matrix, then it essentially goes away. So I'm left with just x. But just like with all other kinds of math problems, you can't mess with the equation. This is what's given. We can't do one thing to the left side without doing it to the right side as well. We also learned that it's very important that you don't mess with the order in which things are multiplied. So because we put the inverse of a at the front over here, I need to put the inverse of a at the front over here as well. So again, it's very important the order in which you multiply these matrices. If I were to take this and drag it over to this side, it would be a totally different problem than if I put it right out here. So that's one thing to be careful with. But as you'll notice, we now have the variable is equal to the inverse of A times matrix B. So if we can figure out the inverse of A and multiply it by B, we get our answers. So let's go ahead and real quick again rewrite this matrix. So just to cheat just a little bit, I'm just going to write negative 3x plus 2y equals negative 12 and scratch that out just a little bit. So my matrix A are the coefficients 3, negative 3, 4, 2. My matrix X is x and y, and my matrix B is negative 6, negative 12. So let's go ahead and figure out the inverse of A. We do so by following just that formula there. So the inverse of A is equal to, I'm going to do it down here, the inverse of A is equal to 1 over the determinant of A times that modified matrix. So we switch the top left and the bottom right, and then we multiply by negative 1 the top right and the bottom left. So negative 4 and positive 3. The determinant of A is by doing top left and bottom right multiplied together minus top right and bottom left multiplied together. So left to right minus right to left. If you need a review of that, go ahead and go back and watch one of those videos. So 3 times 2 is 6. And then 6 minus negative 12, 2, negative 4, 3, and 3. And all of this turns into 1 over 18. 1 over 18, 2, negative 4, 3, and 3. We'll go ahead and do some scalar multiplication, and we'll end up with 1 over 9. And then down here we'll have negative 2 over 9. And then we've got 1 over 6. And last but not least, 1 over 6 again. So this right here is the inverse of A. Let's go ahead and do some matrix multiplication. Is equal to 1 over 9, negative 2 over 9, 1 over 6, and 1 over 6. Multiplied by negative 6 and negative 12. So again, I am allowed to multiply these. A 2 by 2 matrix multiplied by a 2 by 1. So 1/9 times negative 6. 9th times negative 6 plus negative 2/9 times negative 12. And then the next one, we've got 1/6 times negative 6 plus 1/6 times negative 12. So now it's a matter of just simplify and get the solution. Whatever method you end up using to simplify that is totally fine. If you want to use a calculator, that's great. If you want to use a little bit of mental math, these are all relatively simple numbers. But whatever method you use, you should come out to 2 and negative 3. Now what's so special about this is if we go back and look at what matrix X is, we know that it's X and Y, which means X equals 2 and Y equals negative 3. X equals 2, Y equals negative 3. Now, there's a lot of people out there saying there's no way that that's true, or why, how do you know, any of that stuff. Turns out you can check your answers. Remember, this is a system of equations. what we should be able to do is say 3 times 2 plus 4 times negative 3, and that should equal negative 6. So 3 times 2 is 6, plus 4 times negative 3 is negative 12. 6 plus negative 12 equals negative 6. So the answer is yes, this statement is true. Remember, when you're solving a system of equations, you're ultimately looking for what values make this statement true. So if we can prove that these numbers make the first and the second statement true, then we can guarantee that we have the correct answer here. So plus 2 times negative 3, and that should equal negative 12. Negative 6 plus negative 6 does equal negative 12, so we are on the right boat. We now know for a fact that x equals 2 and y equals negative 3. So that's the first method of solving a system of equations using matrices. This method's kind of like an algebra method almost, where you're rearranging the equation, but because we've got matrices, we have to do a little bit of fancy rearranging as opposed to just simple division. The next one is a little bit more complicated. It's called Cramer's method. So the benefit of Cramer's method is it actually allows you to solve for individual variables. So if I only wanted to know what the x variable was, I could use Cramer's method and solve solely for that x without having to worry about y, or if there are more variables, z or any other variable that does exist. Cramer's method will also use matrix A, where matrix A is again the coefficients in front of x on this column, so 3 and negative 3, and the coefficients in front of y on this column, 4 and 2. We've got our variable matrix filled with x and y, and then we've got our answer matrix filled with negative 6 and negative 12. First step in Cramer's method is going to be to find the determinant of A. The determinant of A is when you do left to right minus right to left. So 3 times 2 minus 4 times negative 3, which gives us 6 minus negative 12. So 6 plus 12 gives us 18. So that's nothing new with Cramer's method. Here's the little tricky bit with Cramer's method. Cramer's method, we need to create a matrix called A sub x. A sub x is going to be matrix A, except instead of the x column, we're going to replace that x column with the answer matrix. So this whole column right here is going to go away for A sub x, and we're going to replace it with this column here. So let's go ahead and do that. The 4 and the 2 are going to stay. 4 and 2 both stay. But now I'm going to put, instead of 3, negative 3, I'm going to put negative 6, negative 12. So again, that gets subbed in for the x value there. Now that we have A sub x, we need to find the determinant of A sub x. Determinant of A sub x is going to be found the same way that we've been doing it. Negative 6 times 2 minus 4 times negative 12. Which gives us negative 12 plus 48, which gives us 36. As I said, the benefit of Cramer's method is it allows you to solve for individual variables. If I wanted to know what x was, what I have to do is take the determinant of A sub x and divide it by the determinant of A. So 36 divided by 18 gives us 2. So we have just discovered using Cramer's method that x equals 2. Now if I want to solve for y, I need to do the same thing except do it for A sub y. So A sub y is when you take matrix A, but this time instead of replacing the x, we're going to replace just the y. So we're going to start back over. We're not going to use A sub x, we're going to start back over at just A. So leave the x column, but now replace the y column. Instead of writing 4 and 2, we write negative 6, negative 12. Oh, excuse me, let me change that to white. So now let's go ahead and figure out what A sub y, the determinant of A sub y is. It is 3 times negative 12 minus negative 6 times -3, giving us -36 minus 18, which in this case will give us a -54. Now that we know the determinant of a sub y, we can use the exact same method we did here. Determinant of a sub y divided by the determinant of a will be -54 divided by 18, which gives us, surprise, surprise, a -3. So we have just discovered two different ways to use matrices to solve a system of equations. There is also a third method. I'm not going to cover that in this video. I will cover it in a later video. But for now, the two methods we learned are what I call matrix multiplication, where you're basically doing algebra. You need to know the inverse of the matrix, and when you multiply that by the answer matrix, you will come out with your variable matrix. The second method has a name. It's Cramer's method. You're using a lot of determinants to solve for your individual variables. The benefit of Cramer's method is you can solve for individual variables.